We can see from our last videos where these rules came from. So basically, when we're trying to find the domain of a equation, there are three rules that we need to keep in mind. Number one, if you have a variable in the denominator cannot equal zero. So we're going to make sure to set the denominator not equal to zero. If you have a variable under a square root, we have to remember that stuff under the square root must be positive in order for us to get a real answer. So we're going to set the stuff under the radical or the square root greater than or equal to zero. And for now, pretty much everything else that we're going to work with, definitely all just plain polynomials, they're going to have a domain of all real numbers. There's nothing bad happening. We're not dividing by zero. We're not taking the square root of a negative. You can plug anything you want in and it's going to be fine. Okay, so let's try a couple of examples here. Let's look at this first one. Is there an x in the denominator or a variable in the denominator? No. Is there a variable under the square root? No. Nothing bad can happen with this one. So the domain is going to be all real numbers. And the way to write all real numbers in interval notation is from negative infinity to positive infinity, all the numbers. Remember, infinities always use parentheses, never square brackets. Okay, let's look at our second variable, our second guy here. We have 3x on the top and x squared minus 4 on the bottom. What is the rule? You can't divide by 0. So we need to take this denominator here and make sure that x squared minus 4 is not equal to 0 and solve this. So this is a difference of squareds. We can do a really quick factor. So what we get is that x cannot equal negative 2 and x cannot equal positive 2. Now, occasionally I'll have students who try to set the numerator equal to 0 as well. We don't want to do that. Plugging 0 in or plugging a number into the top to make the top 0 is fine. In fact, we can do it on this one. So if I plug in the number 0 for my x's, what I'm going to get is 0 divided by negative 4. And when I plug that into my calculator, what is 0 over negative 4? Well, that's just 0, and 0 is a real number. It's an answer. So 0 on the top is fine. It's 0 on the bottom that we have to make sure it doesn't work. The next little trick here is that finding how to write this in interval notation can be a little tricky. So let's start by drawing it on a number line. Negative 2 is smaller than 2, so we'll put the negative 2 on the left. We don't want to include them, so we put them in circles. And then basically this is saying shade everything except the numbers 2 and negative 2. So we're going to shade up to the negative 2, and the part that everybody forgets, we're going to shade between the negative 2 and the 2, and we're going to shade above the 2 and go forever. And if you look at this, we've divided our number line into 3 chunks. This first chunk here, we would represent with negative infinity to negative 2, because we're going to go all the way up to negative 2 but not include it. So we use negative 2 as kind of the stopper, but we're not going to include it. And then this middle chunk, well, this is from negative 2, not included, up to positive 2, not included. Again, those 2 and negative 2 are the stoppers. They're not included, but there's all the way up to them is included. And then our last version here is the chunk from 2 to infinity. So this is how we're going to write the interval notation that says all real numbers, but not 2 and not negative 2. Do you see how the breaks happen at 2 and negative 2? A little bit tricky, but I think y'all can handle it. All right, let's look at our last quick example here. This one, we have a variable under a square root. So what we want to make sure is we know in order for x's to be allowed, numbers to be allowed, we have to make sure that the stuff under the denominator, under the square root, is positive or 0, greater than or equal to 0. So we set the stuff under the square root greater than or equal to 0. And now it's just a matter of solving this problem using algebra. So we're going to subtract 4 from both sides, and then we're going to divide both sides by negative 3. And this is a little bit of a tricky spot because we're going to get positive 4/3. But what did we just do? We just divided both sides by a negative. And what do we do when we divide an inequality by a negative? That's right, you've got to remember to flip the sign. So, little trick that can happen, remember it's only when you divide both sides by a negative. Writing this in interval notation, let's just go back to our graph really quickly. So we are including 4/3 because it's greater than or it's less than or equal to, and this is x is less than or equal to, which is shading this way, which means I am going to go from negative infinity to 4/3, and that is the domain of my equation in this case. Now we have two more examples. These are the basic ones because we had a divide by zero, we had a square root, and we had a basic polynomial. But it's never going to be that easy when it comes to test day. These are the kinds of questions you're going to see because what do you see with big F of x here? Is there an x under the square root? Yes, there is. Is there also an x in the denominator? Yes, there is. Teachers love this kind of question because we get to test both things in one problem. So you have to use both rules. The first rule says that the stuff under the square root must be positive. So we're going to set that greater than or equal to 0. The second rule says the stuff under in the denominator cannot equal 0. So we will also write that rule. And now we need to solve both of these. So 3x is greater than or equal to negative 12, and x is greater than or equal to negative 4. So our first thing that we know is that all the x's must be greater than or equal to negative 4. We have to meet that criteria. Then solving our second one, we also need to know that x cannot equal 5, and we have to do both of these at the same time. So in order to get this one right, I always draw a number line. So we're going to put the two important numbers on here, negative 4 and 5. Remember, x cannot equal 5, so we're going to put a circle there, meaning we're not going to include the number 5. X must be greater than or equal to 4, so we're going to use a closed dot for greater than or equal to. And which way do we shade for greater than? We shade this way. But we can't shade the 5 in, so we're going to shade from negative 4 to 5, jump over the 5, and keep shading. And what you can see is we have two shaded portions of the interval of the number line. So what is the interval notation that is going to tell us what numbers are allowed in the domain? We're going to go from negative 4 to 5, and we're going to go from 5 to infinity. What does this mean? It means any number that falls in these two intervals, when I plug them into this equation up here, I will get an answer. But if it's not in these intervals, if I try to plug it into that equation, no answer will come out. My calculator will say no solution, error, something like that, because it's not part of the domain. Let's try this one more time. So again, we have the same problem here. The stuff under the square root cannot be negative, so it must be greater than or equal to 0. And the stuff in the denominator cannot equal 0, so we'll set it not equal to 0. Let's solve each of these, and let's see what the little trick is that comes out of this one. So subtracting 2 from both sides, we don't flip the sign, so we just have x must be greater than or equal to negative 2. This one is going to factor to x plus 3, x minus 1. And solving these two, we get x cannot equal negative 3 and x cannot equal positive 1. So I have three numbers that I have to juggle here, the negative 2, the negative 3, and the positive 1. The easiest way to see what your final answer is going to be is to put all of these on a number line. They don't have to be like spaced correctly, they just have to be in the right order. So we have a negative 3, a negative 2, and a positive 1. Okay. You cannot equal negative 3 and you cannot equal positive 1. So we're going to put circles there, meaning don't include these. Now we're also going to know that x must be greater than or equal to negative 2. So greater than or equal to means we include the negative 2, and greater than means we have to shade this way. But we can't shade that 1. We've already said, nope, it can't be 1. So notice kind of what's happened here is that we have two shaded intervals that are going to be part of our domain. And does negative 3 really come into play in those two shaded intervals at all? It doesn't. It was voted off the island twice. It's going to give you a negative under the square root, and it's going to make you divide by 0. We're just going to completely ignore him as part of our total interval here. But what are our two shaded intervals that are going to be part of our domain? Well, we're going to go from negative 2 to 1, and we're going to go from 1 to infinity. And again, what does this mean? It means that if I pick any number in these intervals and plug them in, I get an answer. Thus, this is my domain.